Welcome all my dear students to Sudharma's physics classroom. Today we are going to learn the topic uniform circular motion from the chapter motion from CBSE grade 9. So already we have covered up to the portion of equations of motion, graphical representation of motion and the numerical based on graphical representations and equations of motion. So let's come to the topic of uniform circular motion. Before learning what is uniform circular motion, we need to know about what is circular motion, right? So what is circular motion? If any object moves in a circular path, we can call it as a circular motion, right? So let's consider these examples here. So here we have the picture of the motion of an athlete along closed tracks of different shapes. Let's see the example of the rectangular path. So this person is walking through the rectangular path and he reaches to the starting position after covering the complete path, right? The next diagram we have the hexagonal path and we have the octagonal shaped track and a circular track. Why we are showing all these shaped tracks when we have the topic of circular motion? So let's consider the case of a square path. So here we have the person traveling from, let's say, A to B. He is traveling in this direction. To move from B to C, he has to change his direction, right? Now B to C. Now from C to D, he has to change his direction again. So that means that the person, suppose he is walking with a constant speed, but he is changing his direction. In the case of hexagonal path or octagonal path, the direction keeps on changing, right? If it is a path of multiple sides, then he will have to change the direction of path multiple times. So when you consider all these examples and a circular path, what you can understand is in a circular path also the direction of motion is changing continuously, right? So when we say the motion is in the clockwise direction or anti-clockwise direction, there is a change in the direction. Okay, so uniform circular motion means motion of an object in a circular path with constant speed. Constant speed is important. Constant speed. I didn't say constant velocity, okay? It moves with constant speed. What do you mean by constant speed? Throughout the motion, the object will be moving with a particular speed. So here the boy is tying a stone on a string and he is rotating it by holding at one end of the string. So when the object undergoes a circular path, circular motion, it will have a speed, right? So throughout this motion, if it is undergoing uniform circular motion, the motion will be having a constant speed and varying velocity. Very important, it will have varying velocity. So what is the difference between constant speed and varying velocity? Why we have to say that it is a constant speed motion and varying velocity motion? When we say it is varying velocity, definitely there is an acceleration. Uniform circular motion is accelerated motion. It is accelerated. So let's bring all these concepts to our mind. We have learned all these terms in the previous discussions. Speed, distance covered by unit time. Velocity, displacement by time. Acceleration, change in velocity with respect to time, right? So what is the major difference between speed and velocity? It is again the unit of speed and velocity is meter per second itself. But velocity is a vector quantity and speed is a scalar quantity. So as I said, even suppose the person is moving with say 10 meter per second. Okay, he is moving with 10 meter per second. From B to C again he is traveling with 10 meter per second. C to D 10 meter per second. D to A 10 meter per second. That means throughout the motion he is maintaining that constant speed. But since the direction is changing, velocity is changing. Magnitude of velocity is going to be constant, but the direction will be changing. That is the important thing. When direction is changing, the physical quantity velocity, since it is a vector quantity, velocity will change. Hope you are understanding. So, uniform circular motion means motion of an object in a circular path with constant speed and varying velocity, and uniform circular motion is an accelerated motion, because each and every instant the direction of velocity is changing. So if you leave the stone, see the example of this boy, if the boy leave the stone at an instant, it will be moving tangential to the position, right? Tangential to that position. Okay, so for the motion of an object under uniform circular motion, we say that there is a minimum force required, and that force is called as centripetal force. Centripetal force. Okay, centripetal force is the force required for an object to move under uniform circular motion. Okay, so that centripetal force will be always directed towards the center of the circular path. Okay, it will be along the radius. So when we say the force is along the radius, the acceleration also will be along the radius, and velocity vector will be along the displacement vector, that is tangential to the position. Okay, so these are the characteristics of uniform circular motion. Now let's see some examples for uniform circular motion. A giant wheel. Giant wheel, it's a kind of rotatory motion also, because it moves around an axis, and it undergoes uniform circular motion if it is moving with constant speed, right? Throughout the motion, all these people will, all this seating arrangement, everything, it's just a complete system, right? So the motion is going to be with constant speed, and it is undergoing a circular path, but each and every instant the direction of motion keep on changing. So this is an example for uniform circular motion. Another example is planets revolving around the sun, or the satellites moving around the planets. All these are examples for uniform circular motion. Again, the characteristics are object will move with constant speed and varying velocity, and the motion is accelerated motion. Another example is hands of a clock, second hand, minute hand, right? Hour hand, whatever it is, it moves with some particular speed. Okay, and it will be changing the direction of motion each and every second. So this also satisfies the condition for uniform circular motion. You can try to find out some more examples which comes under the category of uniform circular motion. Now, when I say the speed is constant, how do you calculate the speed of a body which is undergoing uniform circular motion? We know that speed is equal to distance covered divided by time. Always remember, in uniform circular motion, speed is constant, velocity is different, magnitude of velocity is constant, but the direction is changing. Okay, so if an object starts from this position, okay, it covers a path completely and comes back to the same position. Say the radius of the circular path is r. So how much distance he is covering here? The object is covering a distance which is equal to the circumference of this circular path. So our equation is distance covered by unit time. So the distance covered by the object on this circular path, that is going to be equal to 2 pi r, which is the circumference of this circle. So that divided by time, because our formula for speed is distance by time. So 2 pi r divided by time, and the unit is going to be meter per second itself, because it's our speed, right? Speed. So this is the equation to calculate the speed of an object which is undergoing uniform circular motion. Let's try to apply this equation in a question. A cyclist goes around a circular track once every 2 minutes. Every 2 minutes. If the radius of the circular track is 105 meters, calculate his speed. So time is given in minute. Time is equal to 2 minutes. How many seconds? Whenever we solve a question, we have to make sure everything is in SI unit. So SI unit of time is second. So 2 minutes is equal to 2 into 60 seconds. So 120 seconds. Now distance. What is the distance given here? Circular path of radius 100 meters, 105 meters, right? So r is equal to 105 meters. So our formula for speed is equal to 2 pi r divided by t, 2 into 3.14 into radius is 105 divided by 120. So pause the video, do the calculation, you will be getting the answer as 5.5 meter per second. So throughout the motion, the cyclist will be moving with 5.5 meter per second and his direction continuously changes. Okay, so his motion is uniform circular motion, constant speed motion, varying velocity motion, and accelerated motion. Uniform circular motion is accelerated motion. You can expect these characteristics in an MCQ question. Okay, which of the following is not a characteristics of uniform circular motion? If you get a question like that, you have to do the checklist. You will be checking if it is a constant speed, varying velocity, accelerated. Sometimes they give non-accelerated. Then that is not a characteristic of uniform circular motion, right? Uniform circular motion is accelerated motion. And the acceleration will be always directed towards the center of the circular path. And the direction of velocity at any instant will be tangential to that position. Okay, so that's about this chapter. So we are completely done with the chapter motion. That is the first chapter in physics in grade 9. So if you are watching this video for the first time, please subscribe to the channel and click the bell icon for more updates on the new lessons. And in the coming video, I will be coming with force and laws of motion. That is the next chapter in physics. Okay, so force and laws of motion is again a very, very important chapter in physics. So let's learn that. It's a very interesting chapter. So I'll be coming very soon with force and laws of motion. Thank you for watching. Bye.